Hello friends, welcome to my channel Patra Tutorial. In this video I'll be discussing about Peterson's solution for critical section problems. Okay, so we have already discussed about two different solutions. First one is what, by using turn variable, and second one is what, by using flag variable, right? So the turn variable was satisfying the mutual exclusion property, but it was not satisfying the progress. Okay, and somehow we achieved the progress in by using flag variable, but the system is going into the what, a deadlock state, right? So in this approach, using Peterson solution, we will be combining two methods, or two things. One is turn variable and another one is a flag variable, and we will try to solve this problem. Okay, so let's start. Suppose these are two different processes, P1 and P2. Okay, so both are same process. Only thing is that a few lines of codes are different. Okay, so just let me check this one. Okay, so this part of the code is the entry section. Okay, this part, and this is the exit section, and in between critical section is there. And in this process, this is the entry section. Okay, and this part is the exit section, and in between critical section is there. Okay, so what process P1 doing is that, first, see, there are two things are there. Okay, one is flag variable. Okay, and another one is turn variable. Okay, so turn variable can be 0 or 1, and flag let's say initially it is 0 0. Okay, both are 0 and 0. So this is the first one, this is second one. Okay, this is 0th element, this is first element. Okay, flag is nothing but one array. Okay, it is holding two elements. Okay, one is for P1, this is for P1, and this is for P2. Okay, now see, first we will understand the code, then we will try for three things are there, right? First one is what, mutual exclusion, second one is progress, third one is bounded waiting, right? So first let's understand the code first. Okay, so this is very important. Okay, so what process P1 is doing is that it will change the value of flag of 0 to 1. Okay, so flag of 0 is for P1 and flag of 1 is for P2. Remember this one. Okay, so this is for P1, let me write here, this is for P1 and this is for P2. Okay, so first it will say that I am interested to go into the critical section. Okay, by changing the value of flag of 0 equal to 1 means what, it is declaring that he is means this process is interested to get into the critical section. Okay, then turn equal to 1. Okay, it is giving the chance to P2. Okay, it is just changing the, means assigning the value of turn to 1. Then it is checking while turn is equal to 1 and flag of 1, that means other process, one process P2. Okay, so this part is checking whether process P2 is interested or not. If it is 1, then process P2 is also interested, and if it is 0, it is not interested, right? So if both these conditions are satisfying, then it will execute this part. Then that means what, it will do nothing. But if one of these conditions is not satisfying, then directly it will go to the critical section. Okay, this is the meaning of this code. Okay, so this is the entry section. That means what, it will make sure that the turn is 1 and the process P2 is not interested to get into the critical section. Okay, then after executing the critical section, it will change the value of flag of 0. That means that first element of that flag to 0. Okay, then what P2 is doing, P2 is doing the same thing. First it will show the interest that it is going to, means it is interested to go into the critical section. So it will update the value of flag of 1, that is second element of flag variable, to 1, and it will assign the value 0 to turn variable. That means it will give the chance to P1, and it will check while turn is equal to 0 and flag is equal to 0. So let me put here equal to symbol. Okay, it will check. Okay, so by mistake I have taken only single equal to. So if turn is equal to 0 and flag of 0 is equal to 1, this means what, this is checking whether the process P1 is interested or not. Okay, so flag of 0 represent process 1, right? So if it is 1, then process P1 is also interested, right? But if one of these two conditions is not satisfying, then it will directly go into the critical section. Okay, if both the conditions are satisfying, it will do nothing and it will keep repeating here only. Okay, if one of these conditions are not satisfying, then it will go to the critical section, and after executing in critical section, it will update the value of flag of 1 to 0. That means this one to again 0, and again it will terminate. Okay, so this is the code for process P1 and P2. Now let me check whether this code is satisfying all three conditions or not. Okay, so first one is what? So if a solution is satisfying three conditions, first one is what? Mutual exclusion. Okay, so first one is what? Mutual exclusion. Okay, and second one is progress, third one is bounded waiting. Then only we can say this solution is appropriate for a critical section problem, right? So let me check whether both the process can enter into the critical section or not. Okay, so let me start by taking turn equal to 0. Okay, let me take turn equal to 0 and flag equal to initially both are 0. Okay, I am taking this is 0th element, this is 1, this is for P1 and this is for P2. Okay, so initially both are 0 I am taking. Okay, now see, let's say P1 is starting first, P1 will start first. Okay, now it will change the value of flag of 0 to 1. Okay, so this value will becomes what? 1 now. Okay, this is now changed to 1. Okay, now turn equal to 1, so it is assigning the value of turn. Now it will be changed to 1. Okay, now it is checking while turn is equal to 1 and flag of 1 is equal to 1. Now see, turn is equal to 1, right? This is true because turn value is right now 1, but flag of 1 is what? This is 0 only, right? So this is false. So if any one of these conditions is not satisfying, then it will go to the critical section, right? So it will directly go to the critical section. Now P1 is in CS. Okay, critical section. Okay, now it will complete the execution, then again it will change the value of flag of 0 to 0. Now again it will change the value of this variable to 0 only. Okay, so now let me erase this part. Okay, so right now the value of flag of 0 is 0 only. Okay, so P1 successfully completed one iteration. Now P2 is coming. Okay, now P2 is coming here. Now what P2 will do is P2 will change the value of flag of 1 to 1. So flag of 1 is this one and it will change the value of this one to 1. Okay, now turn equal to 0, it will change the value of turn to 0. Okay, now while turn is equal to 0, it is 0, right? So this part is satisfied. Flag of 0 is equal to 1, no, because flag of 0 is now 0 only. Okay, so this part is not satisfying, so it will not execute this line, directly get into the critical section. Okay, so now P2 enter into the critical section, then it will execute this part and again it will change the value of flag of 1 to 0. So again it will change the value of this to 0 and it will come out of the critical section and complete its execution. Okay, now see, P1 completed, then P2 also completed. Okay, one iteration P2 also completed. Okay, so one by one is okay, but can both the process be in the critical section simultaneously? That is what we have to check, right? So now let me start again. Suppose here P1 started again. Let me say turn equal to initially nothing is there and flag equal to initially both are 0. Okay, let me take 0 and 0. Okay, and this is 0th index, this is first index. Okay, now P1 started, P1 changed the value of flag of 0 to 1, so it will change the value of flag of 0 to 1. Now turn equal to 1, now assign the value 1 to turn. Then while turn is equal to 1, this condition is satisfying because turn equal to 1 right now, and flag of 1 is equal to 1, no, because this is 0, right? This is 0, so this condition is not satisfying, so it will enter into the critical section. Okay, now let's say P2 make a context switch at this point of time. Okay, now P1 is executing in critical section and at this point of time P2 is also trying to enter into the critical section. So is it possible or not? Let me check it. Okay, so right now the scenario is this: turn equal to 1 and flag of 0 equal to 1 and flag of 1 equal to 0. Okay, this is the situation now, and P2 is trying to enter into the critical section. So what it will do is it will start execution. So flag of 1 equal to 1. So first it will change the flag of 1 equal to 1, so it will change the value of this to 1. Okay, now turn equal to 0, it will change the value of turn to 0. Now it will check while turn is equal to 0. Okay, this condition is satisfying because turn value is 0 right now, and flag of 0 is equal to 1. See, now flag of 0 is also 1, right? So this condition is also satisfying. So since both the conditions are satisfying, it will execute this part, okay, and it will again check the while. So it will keep rotating here only until and unless this flag of 0 value is not updated, okay. And when the flag of 0 value will be updated, once P1 completed its execution in critical section, then only it will update the value of flag of 0 to 0, right? So the process P2 is rotating here only in the while loop, and suppose P1 completed its execution. So P1 completed in critical section, then it will come out of the critical section and it will update the value of flag of 0 to 0, right? So it will update this value to 0 again, okay, suppose 0. So once it will update the value of flag of 0 to 0, what it will happen is this condition will be false, right? See, it is checking flag of 0 equal to 1, right? But it is 0 now, so this condition will be false, and once this condition is false, the P2 will enter into the critical section, because any one of this condition is false, then it will go to the critical section. So P2 will be entered into the critical section. So from this example, what we have understood is that only one process can enter into the critical section. So until the process P1 was executing in the critical section, P2 was looping in this while loop, right? And once P1 completed, P2 is able to enter into the critical section very quickly, right? So this condition is satisfying the mutual exclusion property, right? So this is fine. So this is fine. Now we have to check for progress, right? So let me take again. Suppose second thing is what we have to check for progress, right? So let me start again. Suppose turn equal to nothing is there, okay, and flag. Let me take flag equal to again 0 0 only, okay. Initially 0, this is also 0, this is the first index, and 0th index, this is the first index, okay, and this is for P1 and this is for P2, okay. Now progress means what? If P2 is not interested or if P1 is not interested, then this process can enter into the critical section as many times as it wants, okay. That is what progress, right? So what we have to do is, let's start with P1, okay. Suppose P1 is starting first. Again P1 is starting, so it will update the value of flag of 0 to 1 first line, then again second line turn equal to 1, so turn will be 1, third line turn is equal to 1, yes, correct, this condition is satisfying. Then flag of 1 is what? Flag of 1 is equal to 1. What is the value of flag of 1 now? 0, right? So this condition is not satisfying, so directly it will go to the critical section here, okay. Now it will execute in the critical section, then it will update the value of flag of 0 to 0. So it will change the value of this one to 0 again, okay. So now it will complete its execution. Suppose P1 completed its one iteration, okay. So first iteration completed, okay. So P1 completed its first iteration and it is trying to enter into the critical section again, and P2 is not interested, okay. So what will happen? Let's see, okay. Now suppose P1 again try to enter into the critical section, okay. Then what it will do again? Flag of 0 equal to 1. So again it will change the value of flag of 0 to 1, and turn equal to 1, again turn value equal to 1, okay. Then turn is equal to 1, it will check the condition, while condition, right? So turn is equal to 1, yes, turn is equal to 1, this condition is satisfying, and flag of 1 equal to 1. So what is the value of flag of 1 now? It is 0, right? So this condition is not satisfying again, so it will directly go to the critical section, no problem at all, okay. So P1 can enter into the critical section as many times as possible if P2 is not interested, okay. So there is no problem at all. So this is how the progress is also satisfying in this problem, okay. Now one more thing we have to check is what? Bounded waiting. That means what? If the current let me write here, okay. So third condition is what? Bounded waiting, right? Bounded waiting, okay. Waiting. So this is what? Suppose P1 is executing in the critical section, okay, and at that time P2 request for the critical section, then after completing P1, P2 must get the chance. Okay, so there should not be any situation that P1 will keep repeating executing in the critical section again and again, and P2 will be in waiting state only. Okay, so after certain iteration, or once P2 requested for critical section, P1 will be able to execute for a certain number of times, not more than that. Okay, that is what bounded waiting. So means after a certain time, or after fixed iteration, or after fixed number of execution, P2 should get the chance. Okay, so just let me check it again whether this is satisfying bounded waiting or not. Okay, so let me take once again turn equal to 0. Okay, don't take anything, turn, just let it be, and flag. Okay, flag equal to initially same thing, 0 and 0, both are 0 0 only. Okay, this one, and this is the 0th index, this is the first index. Okay, this is for P1 and this is for P2. Okay, now let me check, means what I have to check is that while P1 is executing, P2 will request, and after completing P1, whether again P1 is able to enter into the critical section or not, while making P2 in waiting state. Okay, so just let me check it. Okay, so P1 started here. Okay, P1 started here, and it will change the value of flag of 0. This one, it will change the value of flag of 0 to 1, so it will be changed to 1. Okay, now turn equal to 1, so turn will becomes what, 1, and then while turn is equal to 1 and flag of 1 equal to 1, so this condition is satisfying, but this condition is not satisfying, right? Because flag of 1 is 0 right now. Okay, so since this condition is not satisfying, it will directly go into the critical section. Okay, so now P1 is in critical section. Okay, suppose at this point of time, okay, P2 is making request for critical section. Okay, now suppose P2 came here. Okay, P2 came here. Okay, now P2 will start executing simultaneously. Okay, so P2 is changing the value of flag of 1 to 1, so flag of 1 is this one, it will change the value of this to 1. Okay, and turn equal to 0, let's change it to 0. Okay, and while turn is equal to 0, this is satisfying, fine, but flag of 0 is equal to 1, yes, because this is 1 only. Okay, so this condition is also satisfying, so P2 will keep rotating here only in while loop. Okay, until and unless P1 is changing the value of flag of 0 to 0, right? So since this is in critical section only, it cannot update this value, and P2 will keep rotating here only. Okay, now once P2 completed its execution, now see, both P1 and P2 are running, and suppose now P1 is completed its execution in critical section, then it will come out of the critical section, right? Then it will update the value of flag of 0 to 0. Okay, flag of 0 to 0, let me change it to 0. Okay, now P1 completed. Okay, suppose, let me write here, completed. Okay, now suppose once again P1 will try to enter into the critical section. Okay, that is what we have to check, right? Because while P1 was executing, P2 is requested for critical section, but it is in waiting state only. Okay, now we will see, now just avoid P2 and once again try to enter into the critical section, this P1. Okay, so let me try again. Suppose P2 is in waiting state only, and let's try for P1 again. Okay, so P1 will update the value of flag of 0, this one to 1, again update the value of flag of 0 to 1, and turn equal to 1, turn equal to what, 1. Then while turn is equal to 1, this condition is satisfying, right? So turn is equal to 1, this condition is satisfying, this one, but flag of 1 is what, 1, this one, right? So this is also 1, so both the conditions are satisfying, so P1 will be rotating here only. Now see, P1 cannot enter into the critical section because both the conditions are satisfying, so it will be keep on looping here only. Okay, but now if P2 will try, see, now the value of turn is what, 1, but it is saying turn is equal to 0, so this condition is satisfying, and flag of 0 equal to 1, this is okay, but this condition is not satisfying, so P2 will directly enter into the critical section. Okay, so P1 failed, but P2 is successful, right? So after one iteration, P2 is getting the chance. Okay, that means while P1 is executing if P2 request immediately after completing P1, P2 should get the chance. Okay, P1 cannot repeat again in the critical section. Okay, and that is what bounded waiting is, right? So after one iteration only, P2 is getting the chance if it is requesting in the middle of the execution of P1, right? So this represents that the bounded waiting is also satisfying in this solution. Okay, so this approach is satisfying all three conditions. First one is what? Mutual exclusion, and second one is what? Mutual exclusion, progress. Okay, progress, and third one is what? Bounded waiting, right? So Peterson solution is satisfying all three conditions for for critical section problem. Okay, so now we have achieved the two process solution for a critical section problem, right? And that is what? Peterson's solution. Okay, so I think you have understood something. I don't know. And thanks for watching. And if you like my video, please like, comment, and share. Also subscribe my channel Patra Tutorial. Okay, so thanks for watching.